Is everyone ready?
Yeah.
Sweet. All right. I'm Mary Gibbs. I am a senior data scientist at Teal. And what is Teal, you might ask? Teal is a small startup, and we have a platform that helps the job seeker in their job search and career progression. Go check it out. It's really amazing. I like it. I'm not biased at all. So yeah, if you want to talk Teal after, let me know. And today I'm going to be talking about keyword extraction techniques for job descriptions and strategic resume tailoring, and that is a mouthful. Yes. But don't worry, I'm going to break it down. So I started at Teal in October, and one of the first projects I get tasked with has to do with keyword extraction, and so I'm going to talk about my journey in that problem space to you tonight. And little disclaimer here, the viewpoints that I talk about are mine, not necessarily those of my employer. Got that out of the way. So keywords. Why keywords? So when navigating a sea of information, we want efficient discovery of relevant information. And keywords are great. When you search for things on the internet, what do you use? Keywords. They're great because they're concise and impactful and a good way to get a lot of information across quickly. How do they work in the job search? So job descriptions are what employers put out, and they act as a vehicle for employers to let candidates know what skills and qualifications they're looking for when they're hiring for a specific role. And resumes are a vehicle for candidates to express those skills and qualifications. So the tool I'm going to read was basically, keep this in mind when you're applying to a job, and because employers search for keywords, so try and incorporate those keywords somehow into your resume to highlight your experience and qualifications and skills. So, do I have to do this for every job description? I'm like applying to like 50 jobs. That's a lot, right? So, this tailoring your resume for each job. I lost the mic again.
Mic drop number 2.
Mic drop number 2. Okay. No, I cannot see it. Technical difficulties.
We're in suspense of the answer to the question.
I know. Maybe I'll just leave you hanging.
It's been fun, y'all.
If it's not been great, I'm done.
Yes.
I feel like
Praise good, but
I'm gonna say it
All right, I think
Scam
we're
move.
good. Okay, I will try not to hit it again. Okay, so where did I leave off? Tailoring your job application and resumes. Yeah, tailoring can be really time consuming, right? So can we help the job seeker be more effective and efficient in their job search? And also benefit the employers, because then people are highlighting what those employers are looking for.
Can I add a comment?
Sure.
Here you said that employers search for keywords. It's really not the employer. They are actually automate this searching algorithm that actually do the screening of your resume.
ATSs do exist, but humans still review resumes.
it's pretty human.
We're very human.
Humans still review resumes. ATSs exist, but humans still review resumes.
Yes.
Keywords are important for even
No,
both.
the algorithm look for keywords too.
Yes, sure.
Same thing.
So, yeah, can we help the job seeker be more efficient? So can we streamline resume tailoring? And so when I first described this problem, I'll just hold it. Okay. So when I first described this problem, How many of you thought keyword database? Let's just like take, no one? Okay, well, okay. Keyword database. So, yeah, right? Why don't we just create this big database of keywords, and we will identify keywords in the JD by performing a lookup, and then look up keywords in a resume, and then highlight matching and missing keywords, right?
Makes sense?
Yeah.
Makes sense.
Structured data, which is great, we love that in the keyword. We can also add some labels too to help people, like looking at hard skills, soft skills tools. Efficient and fast search. A database lookup is really quick, right? Good for the user experience. We like quick. So, Ship It Squirrel says ship it. Let's go for keyword database. I'm done here. This is why this is really fun. Yeah, we're done. That's the talk. All right. Keyword database, great starting point. Pretty effective. But there's some problems with it. Some of the problems is that a keyword database, usually you have a human curating that in some way. And keywords tend to change over time. So, taken exactly from a ML engineering job description, strong knowledge of AI model architectures, especially general models and LLMs. If we look back to this role 5 years ago, would generative models and LLMs be on these job descriptions? Probably not. Fields change over time, and different skills and qualifications arise over time. And so this is just in one domain, but imagine doing this cross-domain. It's a lot of work, a lot of humans. So how can we improve upon that? And then the other point is keyword database lookup is not context aware. It's just a pool of words. So for example, say we have the word genetics in our keyword database, and we would probably want that there because if you're applying to like biomedical engineering, genetics related jobs in the biotech space, you probably want genetics on your resume. It's probably in the JD. However, say we have an ML engineer JD, and part of the JD has a statement that says that the employers do not discriminate on the basis of genetics. And I'm a data scientist, and I actually did work with genetics data in the past, and I implemented ML pipelines to perform inference on large genetics data sets. I like having genetics in there because it provides context. And this bullet point is relevant to the ML engineering job that I'm applying for. And we show this to a user as this is a match, and it goes towards, like a match score, something that we're trying to show to help the user see how their resume aligns with their JD. It's not great, and this can happen a lot. So the big takeaway from here is when it comes to keywords, context matters. And so, but Mary, you're showing me an example where this is probably at the bottom of a JD. Why not just parse the JDs and then get rid of the parts you don't want and then do this lookup? Something to consider, but JD formatting can be really inconsistent across companies, and JDs are mostly unstructured. So you still run the risk of returning irrelevant keywords because the approach is not context aware. So let's try and make this better. So I'm going to talk a little bit first about some keyword extraction techniques that exist out in the wild that people have been using. And then we'll dive deep in on the language models and the LLMs that you probably all came here for. So, where am I going to start? Instead of having this giant pool of keywords, why don't we do something where we extract keywords directly from the JD of interest that the user is looking at? Because the JD does provide context, right? And also extracting keywords directly from the JD of interest, we can adapt to evolving keyword trends pretty easily, right? And so there's different ways that we can extract keywords. We can do some supervised approaches and some unsupervised approaches. And this table here shows some criteria to consider when thinking about these types of approaches. So in regards to data, supervised techniques tend to require a lot of labeled data, whereas unsupervised does not. So unsupervised has the advantage in that we can quickly get going with it. Context, supervised can learn context and can have a good understanding of context, where unsupervised techniques, depending on the method, are potentially less sensitive to it. Supervised can be more accurate than unsupervised. I think the big ones are generalization. So supervised, depending on your training data, it might not generalize to new domains or unseen data. Unsupervised, you might be able to get around that better. Again, these are all things that are likely, but you'd really have to test them a little bit more. And then resource intensity, like training a supervised model with compute resources and label data and training versus not having to do a lot of that with unsupervised. There's some trade-offs here. And I will say, I didn't mention it, but semi-supervised approaches would probably fall right in the middle of these like pros and cons between supervised and unsupervised. So I don't have the luxury of a lot of JDs with labeled keywords. I work at a startup. Enough said. Not that we couldn't get it, but I think going with the unsupervised approach for me made sense right off the bat. Okay, so a lot of words on this slide. Ignore the words. Listen to me. Okay, so I like to start when I get into a problem with some of the simplest approaches possible. Why? Because simple approaches are easy to implement and scale, and also if the quality is good enough that it's acceptable, like great, it's better. We can always make it better, but I like simplicity. And so one of those is rapid automatic keyword extraction, or rake. And I like rake, and then it makes me think of we're raking the keywords out of the text we're giving it, or pulling them out. So this algorithm basically, you take away delimiters and these things called stop words, like the, and usually keywords tend to sit in between delimiters and stop words. And then and then the ones that we pull out are those candidate key phrases. And then in those candidate key phrases, we have some content words. And then we do, for each content word, we do some things where we look at co-occurrence of words and frequency, and then come up with a score, and then we rank by a score, and then the top ranking keywords are the keywords for that text. It's really not that hard. You can program it pretty easily. Great. Okay. Here's an example of rake. So this is a small little paragraph. I'm not going to read it to you. But we have some keywords down at the bottom. And a lot of them seem pretty relevant to what that text is talking about. But two major parts, is that really relevant keyword? Sharing pipelines? It's good. It's not bad. It's not great. But starting simple. Okay, so now we're going to take a small little detour. Because now we're going to get into language models and why we go this route. Okay, again, more text. So language models. I just want to highlight here that with language models, different architectures for different purposes. Remember that. If there's something you take away from this talk, this one's important. Different architectures for different purposes. Okay, so encoders. How many of you have heard of word to vec? Raise your hands. Glove. Bird. Great, cool. These are encoders. And they encode natural language into something known as an embedding, and that embedding captures contextual semantic relationships. Don't worry, we'll talk about that a little bit more in detail later. And usually we use these for named entity recognition. Text classification does a really good job of representing a piece of text that we can then kind of bucket into our labels. There's other tasks for them, but those are some of the main ones. And then something like decoders. How many of you have used ChatGPT? Okay, I'm not calling it ChatGPT, I'm calling it ChatGPT the whole talk. You're not escaping it.
I like that.
All right, so how many of you have used ChatGPT? Llama 2. Mistral. Okay. So these are decoders, and they're more focused on text generation, so predicting the next element in sequence based on previous context. And then I'm going to mention it, but I'm not going to talk too much about it in this talk, are the encoder-decoder or sequence-to-sequence models, and basically combining ideas from encoders and decoders. I think one of their main tasks that I've seen them used for is translation, so taking the text in English and going to another language. And they have other purposes as well, but I'm not going to go too deep on them because that's not the main focus. But worth mentioning. Okay, so I told you I didn't really like supervised approaches. I'm not going to train one of these myself, but there are pre-trained models. Love pre-trained models. So let's just take one, and actually this model was, it's called SkillSpan. And this was very close to the task I was working on. It was trained on a data set containing JDs. Great, that's what I'm working on. And the person who came up with this technique had labeled different text spans as either skill or knowledge. And so we have these JDs, and the target is that text label. And so what are bio labels, Mary? I don't know what those are. So bio labels means, really bio means beginning. B is beginning of the entity, I is inside the entity, and O is outside the entity. So if we start with working here, that would be a B skill because it's the beginning. DevSecOps would be an I skill because that's in the middle of the skill, and then the period would be the O because it's outside of it. Great. So let's train some BERT models here to identify and classify these text sequences as either knowledge or a skill. Great, right? And basically, they do pretty well. However, when trying out these models on my JDs, they didn't really generalize super well. I have a lot of different domains. The training data set that they trained on was limited in terms of the domains. And that is something to be aware of when choosing a model, is you really want to get a sense of what data that pre-trained model is trained on, and if it's conducive to your task. And the authors even of the paper were like, domain adapted models outperformed non-adapted counterbots. Okay, so this isn't really going to work. For my use case, I would need to possibly fine tune it or train a new one. I'd have to get label data, compute resources, and then I might have to train individual models for domain adaptation, so I'd have to manage a bunch of different models, and I don't really want to do any of this. But it's worth trying because I learned something. You don't know until you try. All right, one more detour. I promise this is a lot. Okay, maybe there's one more. So we talked about encoder models. We talked about how they can create embeddings, or these vector representations of a text that capture semantic and contextual relationships. And we can use encoders to do this, and SkillSpan uses an encoder, but it was using it for classification, not necessarily for grabbing the representation. But with those embeddings, we can do something cool and try to find similar text. So text with similar meanings, or should have embeddings in the vector space that are close to each other because the texts are similar, so the representations of the text should be similar. And how do we determine if one embedding is similar to another? We can use cosine similarity, which is ideal, especially when you have high dimensional vectors, because cosine doesn't care about the spatial distance, it cares about the direction of the vector. And so two vectors in the same direction will be similar. Orthogonal will be, I guess, neutral, unrelated, and then opposite will be dissimilar. Why am I talking about embeddings and cosine similarity? All right, we're gonna get into it. There's another cool unsupervised, well, I'll call this semi-supervised, because you're still using like a pre-trained model, called KeyBERT. I really like this approach, it's pretty nice. We have our input document, and then we create an embedding of that entire document. Then for each word in that document, we create embeddings for each word. And then we use cosine similarity to find the words that are most similar to the entire embedding document, and those are our keywords. I like it, it's nice. It's cool. Problem, and we had this problem with rake too. We don't get keyword labels. That's kind of a hard requirement, or it would be a nice to have. We can always deal with not having labels later on, but I would like labels if we can get labels. Whereas skillspan had labels. Okay, great. This is good. And so one problem is that we might want to ensure some type of keyword diversification. You might get a lot of keywords that are really similar, like up at the top. And so you can use maximum distance or maximum marginal relevance. I'm not going to go into detail on those, but they're in the keyword documentation, so go take a look. But we can use things to ensure that we have some diversity of keywords too, that not all of the ones that we pull are just completely similar to the document and each other. Okay. Now, Mary, why did you try all these approaches? Just throw it into an LLM. Just create a prompt, have it take in a JD, perform keyword extraction, and it can assign labels for you too. Why didn't you do that first? Because I really like simple approaches. No, great question. Because I wanted to see what else is out there and what else would work. And I'm sure, what's your drink of choice? Negroni Sbagliato, I don't know if anyone's seen that, it's mine. What's your LLM of choice? In this case, OpenAI worked pretty well, and GPT-4 was great. Can't say it. It was really good, the performance was really good, I was really happy. Okay, so how am I gonna compare across methods, right? Because I tried out 4 different methods. I tried out more than that, but I'm only showing you 4. I need to say, all right, is the LLM really better than the skill span or the keyword or the rake? Subjectively, I can tell you that it is from reading a bunch of things. But when you start looking at keywords, it kind of gets to be a lot. And I'm like, is it really better? Wait, this one had the same one? Like, you have a lot of keywords, like it's hard to keep track. So let's kind of come up with a better way to do this. Let's quantify it, let's add a metric. So some things we have to take into consideration are that keywords can vary in length. So hypothetical, I have to backtrack because I forgot. I did get a small little JD data set that I had humans label for keywords. I just can't get it at a big scale. Or I just didn't get it at a big scale. But I can use that ground truth set to compare our techniques. So anyway, keywords can vary in length. So say we have a human label a data set and they pick out product. And then one of our extraction techniques picks out product management. Do we consider that a positive result? Or do we need an exact match? I was a little lenient. I used something called the token set ratio, which is in the fuzzy matching package, which looks at the tokens in the key phrases. And essentially it kind of picks up on, like, if product is in product management, we'll consider that a match. So for all intents and purposes, that would be a match. A little lenient, but I just need a sense of if one is really better than the other. So keyword output can vary in quantity across these different techniques. So even though I told my LLM to only give me 30 keywords, most relevant keywords, it would give me 52. It didn't really like to listen, and there's no way I could ensure that it would give me the amount that I wanted. It didn't like to listen. But then all the other techniques too have varying outputs, which makes it really difficult when looking at performance metrics, because technically, say like method A gives me more keywords than method B. Method A might look better in terms of some performance metrics because it has a higher probability of a positive result just because it gave me more keywords. So that's not great. You have to be careful about that. And then the other point too is that not all methods give me a relevance ranking. Not all methods rate these are the most relevant keywords with some type of score. Like an LLM is not going to give me a score for why it thought this keyword was like the most relevant keyword, although I could ask it and it will probably lie to me. So these are a lot of problems that you have to consider when evaluating these methods. And I did my best. And I was like, let's just try a combination of performance metrics. We have a positive result, we have a negative result. Let's use some classification metrics, like let's look at a confusion matrix, precision recall, Jacquard similarity, but again, with really careful interpretation because of some of these things that I've highlighted here. But in general, looking at a combination is really helpful in thinking about this. And from assessing these performance techniques, we have a ranking. LLMs greater than keyword, greater than rank, greater than span. Yay, LLMs. Ship it. Let's go. That's why they pay me the big bucks. We just use the LLM. We're good to go. Not so fast. I have a love-hate relationship with LLMs. I really like them. They're really powerful. Everyone here, sure has tried ChatGPT. It's pretty insane. You can write a whole essay on the Great Gatsby for me. It's really cool. But there's some drawbacks. So there's a lot of variation in JDs. And if we're passing a JD into our prompt, LLMs can be sensitive to input phrasing. And they may or may not consider all parts of a prompt equally. So there can be variation in our outputs. And even like ambiguous elements in prompt, like I'm gonna tell it, give me the most relevant keywords. Well, relevant's subjective, because even with humans labeling JDs, you could say, I could look at what keywords you label in another one, and they could be two completely different sets of keywords. It's subjective. And so that can be tricky. Some other things is that there's limited control. So if you have a user interacting directly with these things, they might produce outputs that don't necessarily align with user expectation. Even if you put in guardrails, it could just throw back things that are not relevant to the JD, and that's problematic. And I think the biggest problem we were having is that response speed can vary. When I was benchmarking some LLMs, it was taking several seconds to get back responses to give me keywords. And that doesn't create a great user experience. Like, I don't want to sit and wait on a platform for like 10 seconds to give me keywords. I want them now, or I'm going to leave your site. It's not great. I'm pretty sure this will get better over time, but from my perspective, it's not quite there yet. So with that in mind, we need to figure out how to proceed, right? I gotta come up with something that has really good quality, that takes into consideration the context, that gives me some labels, and is fast. It's a lot of demands. I'll figure it out. And I did, for the most part. Okay, so we're gonna go on we're going on one more detour, everyone. I want you to think about what I've talked about so far during this talk. The first point being different architectures for different purposes. We saw encoders are really good at getting context. Decoders are really good at generating output and extracting keywords in this use case. And I want you to remember that we can create embeddings and do similarity to find things, pieces of text that are similar. Now, where am I going with this? Does anyone know?
Maybe you can take the whole resume and just put an embedding on it, and then put a job description, and we can have that embedding for that too.
Nope.
'Cause
Well, I mean, that's not where I went, but I don't.
Something to try.
It's not a bad thing to try.
fine-tune using mass language.
Nope, not where I went, but
I lost track of, wait, what did you say again?
where did I go from here?
From here, based on comparing what two things? Was it good?
From what I've shown so far, in terms of LLMs are really good at keyword extraction, but they tend to be slow and not a great user experience. And we have some embeddings in context and semantic similarity.
Did you?
Yeah, so you did LLM to get your keywords, and then from those keywords you embed the keywords, and then you'll be able to find the relationship between the keywords using the call sign.
Close.
Did you, I guess, are you translating the words to the numbers, so maybe you got rid of the words and used only the vectors?
No.
It's some fancy prompt engineering, like saying you're going to tip the LLM and then
Nice try, and I wish it would listen to me.
you got to tip it more money.
They don't like me. All right, I'll give you one more guess, and then I'll go into it.
Yeah, so you get an embedding for the job description, and then you use the decoder to output tailor-made resume for the job description.
No.
No. Okay.
All right, I'm gonna go forward.
What did you do?
I know, what did I do? Contextualized keyword lookup is what I'm calling it.
Ooh.
Hear me out. All right. LLMs are slow, and the user doesn't have control over what they see, but they're really good at doing what I want. What if I use them? I have a JD embed. I have a bunch of JDs. Let's just put it that way. Why don't we pre-extract keywords from these JDs using my LLM? So if I pre-extract, I get around the speed issue, and then I can do some quality checking, ensure things look relatively good. Although at a large scale of JDs that might be problematic, but if you do it in small batches, you know, I think we can do some things to look at the quality of the keywords. All right, so I pre-extract them. And I take all the JDs and their keywords, and then for each JD that has keywords, I'm going right to left. I know it's not intuitive, but we're just gonna go that way. I'm going to also pre-compute JD embeddings that are associated with their keywords. So I have a JD, its embedding, and then the pre-extracted keywords. And I have this all in a vector database. Then, say a user saves a new JD. It's not in my existing data set. JDs can be pretty similar, especially in certain domains. Like a lot of them are going to contain a lot of the same keywords or phrasing. So let's take the new one. Let's create an embedding of that. Then look to find similar JDs in our vector database, and then look at their keywords, and then direct match into the JD that the user saved, and show them those. It's a lot. This gives us, reduces, the similarity search is fast, and the keywords hopefully will be good, and we'll hopefully have similar JDs because we have a large user base saving a bunch of JDs, so they'll be current. And then we're only going to show the user what keywords are already in the JD that they saved, so we're not showing them anything that's not already there. So you get a little more control. That's where I went with this. I'm going to pause here for any questions before I move on.
Can you speak more about vector databases with advantages like you select one?
I have a whole slide on that, but we'll get to it.
How do you ensure that the JD that the user saves has like the keywords, like basically false keywords don't arise from a similar JD?
False keywords don't
like
arise.
the keywords that were in the vector database JD that's most similar to the user JD, but that aren't in the user JD.
That aren't in the, well, because we're exact matching to what is in that user saved JD, we're not going to show them anything that's not in the JD.
How are you monitoring the similarity distance between the JD embedding and the pre-computed JD embeddings to monitor to make sure that you're not serving pre-extracted keywords that are really different?
So like a cold start problem. So say we don't have any similar JDs in our vector database already. That's a great question. I thought of that one.
Or if we have a JD for a machine learning engineer who also juggles chainsaws, like dual hybrid role, like, probably not a lot of similar JDs.
Probably not. Yep, yeah. That's fair. In that case, the dual juggling, two questions. Let me kind of grab that. All right, so if we have a cold start problem, so say we have a JD that's not similar in our database, just default to the original method. We already have keywords, just do what we've been doing already. It's not great, but it's still okay. And then when we run our offline pipeline to update, that JD will be included, and then we'll go back and update it later on, make it better. Oh wait, there was one more. What was it? There was the juggling chainsaws and.
Or it's just how you're monitoring that, sort of what distance or what similarity metric you're using.
To what we consider similar.
Mm-hmm.
I'm setting a threshold right now. For now. We can make that better. Not the end all.
How'd you pick the threshold?
We're gonna get to that, George. I promise. Any other questions? And then last question, and I'm gonna go forward.
I don't understand too much, but from what he said, if you had individual jobs of the chainsaw juggler, couldn't you, does it have to be one thing you match it to, or could you match it to both the MLE and also the chainsaw juggler?
Hopefully, due to the nature of the JD, we would find if the two roles are in one, but they're dissimilar, hopefully, my hope is that they would arise in that similarity search in some way.
That you'd have just one JD that it matches to?
We would have, I don't want to say this. Hopefully there would be elements of one JD that's specific to chainsaw juggling and one that's specific to ML engineering, and they would be in the similarity, and then we could pull keywords from both of those.
So then you don't want something like, you can't even understand it, it's like why there's no keywords for that, but it's a keyword that's like a combination of jobs, not some eldritch.
Don't quite understand what you're asking, but we can talk later.
I guess basically a job that nobody understands.
Oh, then we would just default to looking for keywords in our existing just database without the context if we don't find something similar enough.
So can I make sure I understand what I think you're describing? Because this is fun. This is like
Yes.
not something I've seen before.
Last question though, so I want to keep going.
Okay, so you get a new JD and you say, is this similar to some of the other JDs I've already prepped?
Yep.
And if it's similar within some threshold, then you take the pre-extracted keywords associated with the pre-processed JD and return them. And
Not return, we will return them, but then we'll take them and look in the JD that the user sees, and if they're in there, we'll highlight them. So like your exact matching what was pre.
or use them. Okay, so
Yeah.
tell me how you use them then. What?
So we'll get our keywords back from our similar ones. It's a pool of keywords, and then for each keyword, we'll look in the JD that the user saved and see does this appear in there just by doing an exact match.
Okay.
For exact lookup.
Yeah.
So the only things we're showing the user or highlighting are things that we found in similar ones and that also already exist in the JD the user saved.
So it's safe too.
Yeah,
Like,
it's
on top of being fast, it's safe.
a little bit, yeah.
You're looking to see if it's in there.
Yeah. Okay. No questions at the end. We'll do more. We're going to the bar. I will answer all of the questions. I promise. Okay. Now let's talk about experimenting with. Oh wait, I forgot to say something. Yeah. So great approach. Kind of cool approach. I like it. I dig it. But for this thing to really work, there are several things that need to happen, and I'm going to talk about experimenting with each one of them. One, we need good quality embeddings, right? We need to make sure that the embeddings are good so that we can find things that are really similar. Two, we need fast vector similarity search because cosine similarity is not necessarily cheap, especially when you have millions upon millions upon millions of JDs. And the other consideration is we really, really need excellent LLM keyword extraction. We want really good quality keywords. We need to make sure that happens. Or we're back at the same point we were before with that keyword database, giving not so great keywords. So 3 things. Okay, so now I have to pick an embedding model. I'm not going to train my own. I don't want to. Where do I start? I actually just went with Hugging Face as a semantic textual similarity leaderboard, and I started there because if it's doing well on a lot of different benchmarks, maybe it'll do well for my use case. Not bad idea, right? Then the next thing I looked at was the max sequence length. So encoder models can only accept a certain size input. And so if your text is over that input, you will have to truncate the text. So I need something that can cover most JD sizes. But if I end up truncating, I think there's enough for the models I picked. There's enough in the beginning and middle of the JD that I have enough context to do a good enough similarity search. The other thing to consider, I've talked about this already before, check what data that model was trained on. That's pretty useful to know, especially if you're trying to figure out if this is really going to be good for your particular use case. I think one of the better ones I used, I think it was actually trained on some JDs and Reddit and like some parts of the internet. I don't remember all of it. And then model size is important too. The bigger your model, the more complicated, more computation, more intensive, potentially slower. Model size is important, so really think about that one too. And then once we pick our model, there's some knobs to turn. George Bruni gave a great talk about this last data science DC talk. He talked about things like text chunking and pooling. I'm not going to go into detail here, but if you're interested, talk to me after. We can talk more about that. He did a great job in his talk talking about that. But those are some knobs you can turn to experiment with and improve quality of embedding. And then how do I evaluate? I didn't really have a good solution to this one because it's hard. So I kind of did some experiments where I would pick a query JD and then manually select NJDs that are similar and see if they come up in my search results with a certain threshold and then see how they rank, and that was okay. But then I ended up doing lots of testing and lots of reading, and George, I really want your 22-year-old. Can you send them my way to help me read through all these things? Because that was me reading through all of these things and just checking quality and seeing what really worked for our use case. And the danger of that is that I think it does pretty well. I might not know all the potential edge cases because I can't run through everything. Do I think there's a better way to evaluate these things going forward? Yes. But I didn't have time to do that right now. But I will do them eventually. Okay. Now, experimenting with vector databases. There are lots of vector databases out there, like lots. Pinecone, I think does AWS have their own? Yes, AWS. I really like open source, so I was experimenting more with open source ones. I didn't have time to go and play with all of them. I started off prototyping with Redis, and the only reason I did that was because I've used Redis before and felt comfortable with it, and they have a way to do vector similarity search, so I was like, let's just start there. It's not the end thing we're probably going to go with, but it's familiar, so it's good when you're prototyping. And then I ended up working, after talking to a colleague at NVIDIA, with Milvus. He's using Milvus. He's like, check out Milvus. I was like, all right, why not? And so there's some criteria to consider when choosing a vector database. Redis is not really a dedicated vector database, whereas Milvus is. From my experience with Redis, you were limited in terms of indexing strategies, and indexing strategies really play a big role in your result quality and the speed. There's definitely a trade-off there. Redis was more limited. Milvus had a bunch. Redis did not have GPU acceleration to my knowledge, whereas Milvus did. Performance, Redis is good quality. I found it to be a little slower than Milvus, although I wasn't comparing apples to apples when it comes to indexing strategies, so take that with a grain of salt. Redis documentation is, for lack of a better word, meh. I really like Milvus's documentation, so some things to consider. Definitely could play around more with vector databases. I like Milvus, so yeah. So what do I mean by indexing strategy? I kind of just glossed over that. So when you have a lot of embeddings, and you have a query JD, and you need to calculate cosine similarity between every single embedding, that's expensive. There's a technique called approximate nearest neighbor search, where you can kind of narrow down your search space based on clusters or things like that, so that you're not searching the whole thing. Approximate. And there's different ways to go at approximate nearest neighbors with different indexes. There's graph-based, quantization-based, hash-based, tree-based, there's a bunch. The one that I went with, and we can talk more about this later at the bar, was basically Milvis's IVF SQ8, which is a quantization-based one, where you basically divide the vector database into a certain number of clusters, and then depending on the number of clusters, you'll set a variable called nprobe, which is going to be the number of comparisons between your query and the existing clusters. Again, we can go more in details about this later, but indexes are important if that's the takeaway. Think about that. Okay. And then, I swear we're almost done. Choosing an LLM, I think you want to, a lot of things very similar to what I talked about when choosing an embedding model. Your context window, what it was trained on, the size, the response quality, and how much resources. Like when you have to use an LLM, you really also want to think not only about when you're prototyping, but how are we going to do this at a larger scale? How much resources, who's going to maintain it, who's going to own it. All things to think about when you're making these decisions. And then, okay, so say I have millions of JDs, right? And I told you that I really liked OpenAI. I don't want to run 2 million JDs through OpenAI because I told you it was slow before and that's going to take forever. So can we take a large set and kind of reduce it and subsample in a smarter way to build up our initial vector database, and then over time we can run the pipeline and produce more consistently, but I need a starting point with good enough coverage that my results are good. I was playing around with clustering techniques. K-means for this use case might not be ideal because with a lot of different JDs, I have no idea how many potential clusters I'm going to have. So leaning more into agglomerative or hierarchical approaches, which can be slower. There's a lot of different implementations on that. I really like sentence transformers as a fast clustering algorithm in their documentation that I ended up using, and it worked pretty well for my use case. Yeah, there's things to play with there. But anyway, on that note, contextualized keyword lookup. Ship it. Any questions?
I was wondering, how is the runtime related to the number of JDs put in? Was it like the number of JDs squared, or?
Runtime for?
You were saying that like putting in through like 1 million JDs would take a lot of time on OpenAI, right? So I was wondering what like the big O or whatever you call it was. Is it like S squared or something like that? Or squared?
So if you're running, you have a list of JDs and you're just running them through the prompts, I guess that would be O of N. Because you're just running through a list.
But it was 14 seconds.
Yeah, so if you have like 1 million and it's like 14, I feel like that varies like a ton. So like take that with a grain of salt.
I
Like
think 100 days or something.
it would be a long time, and I don't have that time. And I think there's some other things we could do there to make. We may not necessarily have to rely on OpenAI. I'm not giving that one away. That's for another talk. Yeah.
Do you have a demo that we can see to kind of see the end-to-end pipeline of how everything fits together?
No.
Right,
And moving on. Yeah.
Okay. I guess I kind of have two questions. Did you end up using like an open source LLM to do your embeddings, or did you actually like run it through something that was in the cloud or something?
Embeddings, not an LLM. I used an embedding model.
Oh, you just use a normal embedding model. Okay. And then the second question I have is, how did you? Okay, you mentioned earlier that you had difficulty getting a JD data set. So how did you?
Small. My test set was was really small.
So, but how did you create the JD data set that you made the keywords in your vector database?
Good question. So when I was evaluating keyword extraction techniques prior, I had a small prototype set of like some JDs that were labeled, right? Not a big quantity. For the vector database piece, I don't need labeled. I can just embed the JDs. So I don't necessarily need labels because that's for the similarity piece. So I view the keyword extraction part separate from the semantic similarity piece, but tying them together.
I like how you sort of cast what's like classically like a span extraction like problem into like sort of a mix of like prompting, but also like into sort of a recommendation problem. So very cool. Did you, when you were looking at like, you know, like basically developing like a prompt for ChatGPT, what Chippity GPT, property. Did you look at using any like large but not that large open source models? Just out of curiosity.
Yes,
like,
I did.
Plan or
I used the 7Bs. Some of the 7B models, like what is it, Llama 7B, Mistral 7B.
Yeah. Okay.
Quality was just not as good.
Okay.
And if I wasn't getting good enough quality just on like a small set, I was like, if we go even larger, like I just don't see it.
Sure.
I have another idea on that smaller open source approach. Come find me, we'll talk.
Okay.
And that also, I'm trying to save that for another talk.
Right.
Okay.
So that was for the AWS guy. I did something somewhat similar. Of course, yours is a lot better. But I can, if anyone want to check mine and stuff, I can send it to you. Just come out. And the second thing is, when I was doing something similar, a lot of websites have strict restriction for web scraping their JDs. And the only one that I found was dice.com. And do you find anything other than dice?
Not gonna disclose that. I can't talk about, I'm not talking about that.
Oh, okay.
So this is not really a technical question, it's sort of an abstract question. It's a drift question. So you know, when we're talking about like the keywords that may exist today in certain things, like around LLMs, wouldn't have been present in the past, right? So it's sort of like, I mean, it's sort of, the question I'm trying to ask is around how do I know when what I've trained has drifted far enough from what's live in the field that it's time to retrain. And I know, so you know, I don't know about the APIs to get the JDs, and I just heard you say like I can't disclose how, you know, blah, 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 blah. So, but just at an abstract level, how might you approach that kind of problem?
So Teal is great because our users save JDs. So we have a JD data set. And how would we know when we need to update that database? That's hard. It's very hard. I don't know if it's necessarily a when or a should we just be updating it, continually running this pipeline every week, every month. I mean, how often are keywords gonna drift? How fast? I think maybe once a week updating it, or once a month by taking the latest JDs that our users have saved would be sufficient to avoid that problem.
Let the market decide.
Yeah. Okay, I'm gonna do one more.
Yeah, so with the vector similarity approach, right, what you're doing is you're looking at similar JDs and then looking at keywords that are also present in the new JD.
Yep.
Isn't that guaranteed to give lesser number of keywords compared to if you did it individually?
So direct extraction from the new JD versus
Doing the vector similarity.
potentially. But the problem with doing the extraction direct from the JD with the LLM is that it's slow.
Yeah.
So that's why we did that approach to get around the slowness.
Right.
So you could potentially return less. It really depends. I don't have a good sense of that.
And also as a follow-up for the drift question, what if we like look at on average if the vector similarities are decreasing over time, and then maybe that means that there's a difference between the stored JDs and what's coming in here.
For certain keywords.
Yeah.
Something to look into. Yeah. I wasn't sure Yeah, I don't know if monitoring versus just consistently updating. I don't know. Something to further explore.
I just had a question. You said that all of your database of JDs are user inputted now. How would you then screen for like bias? So like those JDs wouldn't infect other JDs that are getting inputted for like keywords that are.
I'm not sure how much bias plays because we're just extracting direct from text, like the given text. Let me think on that one more. Can I be done?
Yeah.
Awesome.